So today we'll be talking about video games and the game industry in connection with artificial intelligence, especially the quest for artificial general intelligence, or AGI. I think everyone now is more or less familiar with what AI has been able to achieve in recent years. It's been able to do some truly impressive things, and often do these things at a level which would be impossible for a human being. The idea of artificial general intelligence is an idea about where AI could maybe go in the future. It's still very much a hypothetical idea, but it could be thought of as a goal to work towards. AGI would be a generalised model of human intelligence that could turn its hand to whatever it's asked to and generally work to pursue human objectives for the betterment of society. Rather than building an AI system which could be really good at one very specific thing, or very good at learning how to do one very specific thing, we could try and build a super powerful AI machine which models human intelligence generally, that could theoretically learn how to do anything. There are a growing number of AI game generators, which based on user input, commands given, parameters set, images provided, and so forth, will generate entire playable video games. Although the results are impressive from a technological perspective, they're often less impressive from an artistic one. The results are generic and need much more work and refinement by humans to actually be good, interesting, or innovative. Given how quickly AI has been developing, we could perhaps see attempts at a game design version of AGI in the future. A machine which would need much less user input and could apply its intelligence to generally figuring out how gaming could be better, how games could be better designed, and which would autonomously design masterpiece video games of its own accord. We'll get into all of this, but first off, what is artificial intelligence? What even is AI? To put it mildly, this is a problematic concept. Can a machine really be intelligent, think, or learn? What do those words even mean here? What distinguishes artificial intelligence from other computer programs? Given the complexity of these questions, it's not surprising that the meaning of artificial intelligence can be difficult to pin down. There are many machines which can do things that would require intelligence and effort from a human. But we don't call them intelligent because all they do is automate simple, repetitive tasks. Things like coffee makers, robotic vacuum cleaners, and so on. These things are clever, useful, and good at performing specific tasks. But the intuition is that when compared with something like ChatGPT, most people would be resistant to calling them artificial intelligence. They just lack something. So what's the extra dimension required for artificial intelligence? Take AlphaZero, for example, a game-playing program developed by DeepMind, programmed with the rules of chess and trained to play chess solely by playing against itself, with no access to information about openings, endgames, or strategy. In the first 9 hours of its existence, AlphaZero played 44 million games of chess against itself, starting out bad and progressively getting better. In a matter of hours, it went from being absolutely useless to beating the best computer chess system in the world, known as Stockfish. One meeting between the pair gave Stockfish access to information about openings and endgames, as well as a considerable time advantage, and it was a match consisting of 1,000 games. 839 of these games ended in a draw, but AlphaZero got 155 wins and only 6 losses. Garry Kasparov, one of the greatest chess players of all time, had this to say about it. AlphaZero had a dynamic, open style like my own. It prioritizes piece activity over material, preferring positions that to my eye looked risky and aggressive. Programs usually reflect the priorities and prejudices of programmers, but because AlphaZero programs itself, I would say that its style reflects the truth. This superior understanding allowed it to outclass the world's top traditional program despite calculating far fewer positions per second. It's the embodiment of the cliché, work smarter, not harder. Tasked with developing a particular skill through practicing that skill, in a matter of hours, AlphaZero became the best in the world at that skill. A strong intuition we might have here is that AlphaZero learned something, even if we acknowledge that learning is kind of a problematic word for this. The question of what it means to say that an intelligent machine has learned something is a huge philosophical question, and yet the use of the word learning still somehow seems compelling here. On some level, in some sense, AlphaZero learned how to do something, to the point where it outclassed human beings at that thing. It may not even be possible for a human being to play chess as well as AlphaZero does. An article in The Atlantic called "Artificial Intelligence Has Become Meaningless," written by the noted game scholar Ian Bogost, describes a conversation he had with the American computation and artificial intelligence scholar Charles Isbell. Isbell gives two basic criteria for a system to be classed as artificially intelligent, which accommodate those intuitions about AI and learning from the AlphaZero case. The first criteria is that for a system to be artificially intelligent, it must learn over time in response to changes in its environment. The second is that what it learns to do should be interesting enough that it takes humans some effort to learn. As Bogost explains, this definition separates artificial intelligence from mere computational automation, excluding pre-programmed machines designed for automating repetitive tasks like coffee makers. For Isbell, the standard of AI should be higher, reserved for systems that exhibit self-governance, surprise, and novelty. Artificially intelligent systems should be able to observe and learn from their environment and the information they gather from it, progressively getting better, smarter, and more capable, to the extent that they can exhibit novelty and surprise even their creators. In a seminal textbook on AI, a popular handbook called Artificial Intelligence: A Modern Approach, the AI researchers Russell and Norvig refer to a standard model which almost all AI research to date has been carried out in. But this is a paradigm AI may well move away from in the future, perhaps as it works towards artificial general intelligence. On this standard model, AI is the study and construction of agents that do the right thing. What counts as the right thing is defined by the objective that we provide to the agent. In an article called Some Moral and Technical Consequences of Automation, Norbert Wiener cautions that because AI systems can behave unexpectedly, we have to be absolutely sure that the purpose we put into the machine is the purpose we really desire. As the philosopher Tim Crane points out in an article called Computers Don't Give a Damn, this is fine for tasks with clearly defined objectives, like playing chess. It's still a game. It has rules and a well-defined goal, winning the game, the meaning of which can be articulated in advance. But there are many things which we would consider vital to our lives, but have no clear objective or definable purpose to them, like thinking, using language, or being intelligent. If AGI is to become a reality, this leads us to the question of what the goal of intelligence is. For Crane, this question is not obviously a sensible one, and he elaborates on this as follows. What might be the goal of general intelligence? How can we characterize, in abstract terms, the problems that general intelligence is trying to solve? I suppose someone might say that general intelligence is the general ability to solve cognitive problems. This might seem fine until we ask ourselves how we should identify, in general terms, the cognitive problems which we use our intelligence to solve. How can we say, in general terms, what these problems are? Rather than being programmed with a specific goal and ways to achieve it, AGI would be a general model of human intelligence, a machine programmed to be generally intelligent, capable of learning to do anything a human could, which does the right thing in any situation and works for the general betterment of human society. But what on earth does that look like without guiding objectives? What are the right things to use intelligence for, and in which contexts? What are the right ways to think, or things to think about? These are questions with no clear, definitive answers. So how can we make a program that does the right thing if even we don't definitively know what that would be? Russell and Norvig have suggested that we can avoid this problem by not giving clear objectives, instead developing machines that strive to achieve human objectives but know that they don't know for certain exactly what those objectives are. And there are apparently cases where AI researchers have developed experiments where a machine's put into a situation where it has to pursue an objective but doesn't know exactly what the objective is. But this type of research is still in its infancy. If we were somehow to make an AGI, what would the human objectives we would want it to pursue actually be? What should they be? This doesn't make the way forward any clearer. How could we program a machine to do something even we are not sure of the objectives of? Or program a machine to somehow be unsure of its own objectives? These are serious problems for any AGI project, and we can perhaps discern similar problems in the use of AI in the video game industry. Video games have long been an important site of creative experimentation with AI. Game narratives often interrogate AI as an aesthetic theme. Intelligence is artificially simulated to some degree in most video games, and AI is used increasingly in the design process, for better and for worse. Nier Automata, for instance, is a modern classic in which almost all the main characters are artificially intelligent machines. Earth has been taken over by a race of intelligent machines, and you play as human-like androids leading the resistance. The machines that took over Earth develop a strange curiosity about humanity and begin to emulate human behaviour and rituals in ways that always seem somehow uncanny. And as you understand more and more about the enigmatic events which precede the beginning of the narrative, you are put increasingly in the mind of questions about what it means to be human, whether machines could ever become self-aware, and what it would take to achieve this, and take it beyond just imitation and mimicry. AI Dungeon is a game you can play in your internet browser that uses ChatGPT to generate textual stories. The player can take part in them, or let them run their course as they please, once they've chosen certain parameters about the narrative world, including zombie apocalypse, fantasy, mystery, or whatever. Actions the player can take in AI Dungeon include do and say, which are self-explanatory, but also see, which lets you describe something you've seen, and story, which allows you to give additional information, which then affects the story. But generally, when people talk about AI in public gaming discourse, most of the time AI means simulated intelligent behaviour in NPCs, meaning non-player characters, whether enemy, neutral, or ally. Basically, to make gaming experiences as immersive and engaging as possible, characters in the game that are not you should seem real and act in ways those characters might act if they were intelligent beings, what they would do and say in response to their situation. One of the earliest, most basic attempts at simulating different types of intelligent behaviour can arguably be found in the enemy ghosts in Pac-Man, all of which have different behaviours. The red ghost is determined and will always pursue Pac-Man, getting faster the better Pac-Man is doing. The pink ghost is more subtle and will try and ambush Pac-Man by getting in front of him, rather than chasing after him. The blue ghost is shy and will not pursue Pac-Man until other ghosts are nearby. And the orange ghost, Clyde, is a scaredy cat and will pursue Pac-Man but run away when he gets too close to him. Obviously, games are much more complicated and three-dimensional now. But in early 3D games, if you were anywhere near the enemy characters, they would either run directly towards you and attack, or act completely defensively. Then developers introduced the hunting mechanic, in which NPC enemies actively search for the player character if they suspect they're nearby. They listen out for noise, check for footprints, search the area if they encounter the body of one of their allies, and so on. This is a hugely popular mechanic in action and stealth games now. Combat AI became a lot more complicated with the development of survival instinct mechanics, which make NPCs behave more realistically in combat situations. If they're hurt, they'll heal themselves. They'll make use of cover in gunfights, taking cover while reloading or throwing a grenade. If they see weapons or other items in the environment that would benefit them, they might pick them up and use them. One of the best ever combat AIs in a video game can actually be found in the psychological horror game F.E.A.R, the first game ever to use goal-oriented action planning, or GOAP. Usually, game AI was programmed to react in certain ways to certain things at certain times, to respond to certain triggers in certain ways. When they see an enemy, they attack them. When they shoot back, they find cover. When they reach 20% health, they heal. So the AI is programmed to react a certain way in a certain situation. In F.E.A.R, however, the AI were given an inventory of 70 possible goals and 120 possible actions, and were programmed to choose the right goal and best combination of actions to achieve that goal in any situation. If a goal became no longer achievable, a new goal would be selected, a new plan made, new actions selected, and so on. The enemies would constantly be moving, changing positions, crashing through doors and windows, flipping tables for cover, or hiding in dark areas to get a combat advantage. They used suppressing fire, threw grenades to flush you out of cover into their line of sight, fanned out and formed separate mini squads when they entered a room, made flanking manoeuvres, and even played dead. They also avoided a common flaw in game combat AI, which happens when enemies poke their head out of cover during a gunfight. In many games, even today, you can almost guarantee that the head will pop out again in exactly the same spot a few seconds later for an easy kill, which is stupid. The enemies in F.E.A.R would be more likely to pop their head out and then pop it back and move to a different cover without you seeing them do it, which is far more intelligent. Several games have used the GOAP system since. Stalker, Shadow of Chernobyl, Middle-earth, Shadow of Mordor, and Shadow of War, Deus Ex, Human Revolution, and Just Cause 2, to name a few. But this system, for whatever reason, has not become particularly mainstream. Many contemporary games have enemies much stupider even than F.E.A.R, which is arguably still one of the most complete, sophisticated, and effective combat AIs ever seen in gaming, and it's almost 20 years old. But simulating the behaviour of NPCs isn't the only way AI is used in gaming. The scholar Georgios Yannakakis has outlined some other uses which are more about its use in the industry and in the creation of games. The first is data mining, in which AI is used to process information about user behaviour, exploring how people use games, what parts they play the most, what causes them to stop playing, etc. This allows game designers to gather data, which they can then use for marketing purposes, to discern flaws in the game that need to be fixed, and so on. Then there's player experience modelling, where AI systems in games collect and process player information and makes appropriate changes to improve the overall experience of a game. A key example would be dynamic game difficulty balancing, which adjusts the difficulty in a video game in real time based on whether the player is doing well or badly. Resident Evil 4 has this, as does Left 4 Dead 2, Oblivion, Metal Gear Solid 5, Half-Life 2, Breath of the Wild, and the Bethesda-era Fallout games. Depending on how the player is doing in the game will change certain things to make the experience more balanced in terms of its difficulty, which could include changing the amount of enemy health, the enemy's speed, how many enemies there are, how many pickups there are, and so on. Another really important use of AI listed by Yannakakis is procedural content generation, using generative AI to create elements of the game environment, including levels, dialogue, interactive stories with branching narratives dependent on player choice, and so on. Procedural content generation has been a particularly popular technique, with applications both in and out of gaming. In gaming, it can be traced at least back to Rogue, an adaptation of Dungeons and Dragons which randomly generates the game's environment, so the game is different every time you play it. Rogue had a substantial influence on game design, owing largely to its use of procedural generation. The space exploration game No Man's Sky is a good example of a modern use of this technology, featuring a procedurally generated universe with 18 quintillion fully explorable planets populated with flora and fauna. which would take one player around 585 billion years to see. Bethesda's recent space-exploring sci-fi game Starfield also procedurally generated a bunch of its planets. I think we can expect to see AI used in the game industry in increasingly involved ways. Player experience modelling and data mining will likely get better, more complicated, more efficient, and have more capabilities. This will likely be true of game design too. AI will probably be used more deeply and frequently in every aspect of the design process it's currently used in, from generating environments to creating stories, and in the form of AI game generators, create entire games based on user input. There are several game generators already, and will likely be more in the future that operate at a greater level of complexity and sophistication. Currently, however, they're still an emerging technology. A lot of user input is required, parameters to be set, decisions made, etc. Each have things they're good at and not so good at, or specific purposes, so you have to use them in conjunction with other AIs to produce complete content. But given how quickly AI has been developing recently, even by its own standards, and the recent discussion of AGI, we could potentially see developers trying to make a game AGI, which would have an analogous role to the one AGI would have in society at large. In gaming, this would look like an intelligent system which could create any type of game and make masterpiece games autonomously, as well as work generally to improve games, game technology, and game design. The biggest problem with this, as I see it, is analogous to the one I hinted at earlier for the AGI project generally. There is no distinct, easily identifiable objective for thinking, language, learning, and intelligence. And there isn't one for fun, art, or making the game industry better either. There are several things in play here that have no clear specifiable objective, take on many drastically different forms, and often mean different things to different people. How do we program a machine to make something fun, or aesthetically valuable? What's the best way to design games? What makes a game fun or aesthetically valuable is not a question with a single answer, and nor is the question of how best to design games. Games are designed with all sorts of different purposes: to be relaxing, easy, simple, tell a good story, or be punishingly difficult, complex, stressful, and tell basically no story. Some people's ideas of fun will always be contradictory to others, and there is no one correct way to design a game. Any machine programmed to do the right thing when designing a game would almost certainly be reflective of a particular developer's preferences or prejudices. And then we're back to the question of how to program a machine to pursue open-ended objectives. The question of improving the game industry is equally complicated. There isn't a single answer or clearly specifiable objective to this either. There are many things to consider, and programming a computer to address this question would be especially complicated simply because we don't know what game design or the game industry will look like in the future. And there are, therefore, ideas about improving them which we are not equipped to have yet. At the end of the day, one of the things we would ask of a game AGI would be to make good, valuable, innovative art, which is a struggle for AI. AI can generate things which resemble art, or might even stand for passable attempts at art, but I think it's fair to say that AI has never yet generated great art, which innovates and pushes boundaries, or does anything beyond imitating existing art. I'm sure some of you might be aware of one of the greatest singer-songwriters of our age, Nick Cave. Nick Cave has a website called The Red Hand Files, where he takes questions from fans and gives often fascinating and beautiful answers to them. Someone on there named Mark asked ChatGPT to write a Nick Cave song and showed him the results. Nick wasn't impressed. For Cave, the best AI art can do is replicate, mimic, and give a pale imitation of human art. I'll read you a decent chunk of his response, which I liked a lot and I think gets to the heart of the matter. He talks about songs specifically, but what he says is true of any artistic creation, I would say. He says, "Songs arise out of suffering, by which I mean they are predicated upon the complex internal human struggle of creation, and, well, as far as I know, algorithms don't feel. Data doesn't suffer. ChatGPT has no inner being. It has been nowhere. It has endured nothing. It has not had the audacity to reach beyond its limitations, and hence it doesn't have the capacity for a shared transcendent experience, as it has no limitations from which to transcend. ChatGPT's melancholy role is that it is destined to imitate and can never have an authentic human experience, no matter how devalued and inconsequential the human experience may in time become. What makes a great song great is not its close resemblance to a recognisable work. Writing a good song is not mimicry or replication or pastiche. It is the opposite. It is an act of self-murder that destroys all one has strived to produce in the past. It is those dangerous, heart-stopping departures that catapult the artist beyond the limits of what he or she recognises as their known self. This is part of the authentic creative struggle that precedes the invention of a unique lyric of actual value. It is the breathless confrontation with one's vulnerability, one's perilousness, one's smallness, pitted against a sense of sudden, shocking discovery. It is the redemptive artistic act that stirs the heart of the listener, where the listener recognises in the inner workings of the song their own blood, their own struggle, their own suffering. This is what we humble humans can offer, that AI can only mimic. The transcendent journey of the artist that forever grapples with his or her own shortcomings. This is where human genius resides, deeply embedded within, yet reaching beyond those limitations. It may sound like I'm taking all this a little too personally, but I'm a songwriter who is engaged at this very moment in the process of songwriting. It's a blood and guts business, here at my desk, that requires something of me to initiate the new and fresh idea. It requires my humanness. What that new idea is, I don't know, but it is out there somewhere searching for me. In time we will find each other. Mark, thanks for the song, but with all the love and respect in the world, this song is bullshit. A grotesque mockery of what it is to be human. And, well, I don't like it. And this is essentially the problem. To be human, be artistically creative, or work to improve society, is to work within limitations which we constantly strive to transcend, creating new things and pursuing changing, open-ended endeavours without knowing what the future holds. It's far from clear how we could program an AGI, in gaming or elsewhere, to have open-ended, sometimes contradictory endeavours which even we could not possibly know the outcomes of, and yet work towards achieving them nonetheless. This, it seems to me, is the great problem facing AI, certainly facing AGI, and it's unlikely it will ever be solved. Thank you so much for watching. This has been Breaking the Game. Do like and subscribe if you'd like to see more content like this, and drop us a comment if you'd like to let us know what you think. All the best,